recognizing allotropy. This question asks us which of the following are examples of allotropes. So let's figure out what allotropy is in the first place. Allotropy is a property of chemical elements. Notice I'm just saying elements, not compounds here, okay? To have two or more forms. So elements, depending on how they bond, so carbon and carbon, let's say, can bond in different ways to form different things. So when they come together all together, they form different things that have different names and different properties. So we're going to look for things in these answers that are just formed from one element and result from the different types of bonding that can happen for that chemical element. So here, A, we have CO, or carbon monoxide, carbon dioxide, carbon trioxide. And these are all different types of compounds. And so we know, again, we're talking about chemical elements. So here, even though these are different types of compounds that can form, these are not examples of allotropes. Here, we have V2+, V3+, and V4+. These are just examples of different types of ions that an element can form, not necessarily different forms of that element bonded together. So here, this does not count. C, we have graphite, diamond, and fullerene. These are all examples of different types of carbon coming together and forming these different types of things. So we have graphite, different form of carbon, diamond, different form of carbon, and fullerene, different type of carbon. So these are all examples of allotropes of carbon. So this is definitely one of our answers. The next thing we have is red phosphorus or white phosphorus. These result in the different types of bonding that phosphorus can do. They would only have a red color because of the different types phosphorus has, and white phosphorus because of different bonding phosphorus has. So D is also one of our answers. So we have C and D. Let's take a look at E. Ice, water, and steam. This is a tricky one because it involves something that does have different forms, but these are states of matter actually. These are not different forms of a chemical element. Even though H2O is the same, it's still going to be H2O when it's ice, H2O when it's water, H2O when it's steam. It doesn't mean, remember, we're talking about chemical elements being allotropes, so that involves a compound, and this is only about the states of matter changing. So E cannot be one of our answers. So the answers to this question are C and D.